Let's examine a problem that asks you to determine the empirical formula of a substance from chemical analysis. And of course, this chemical analysis gives us data. So here's a problem. It says mercury Hg forms a compound with chlorine Cl that is 73.9% mercury. So we start with that, right? Organize your data, information. And 26.1% chlorine. Determine the empirical formula. Now, if you are not given a starting amount, like meaning the weight of the sample or the compound, like if you were in the lab, you would collect it, would have been 5.678 grams, for example. Then if you're not given that, then all you have to do is assume you have a 100-gram sample. Why? Because it makes life easier. 73.9% of 100 grams is 73.9 grams of Hg. 26.1% of 100 grams is 26.1 grams of Cl. Correct. Now, let me give you a word of caution here before you continue. Sometimes we're inclined to think that if we have a higher mass, like we can tell that Hg has a higher mass than chlorine, then we may have more of this stuff, in this case mercury, than chlorine. But it's not always true. I can have a box with only 1 watermelon and 7 apples. The weight of the watermelon is going to be more than all of the 7 apples combined. But that doesn't mean I have more watermelons, right, than apples. So keep that in mind. So mercury, in this case, has the larger mass, and chlorine is less. So the next thing you want to do, the next thing is you have to convert to moles, because the mass doesn't tell us much about how many atoms. So we have to convert to moles. So the next thing you want to do is you want to convert the grams of Hg to moles. So here we go. So we did that previously, where we went from grams to moles. Okay, so we need to go to the periodic table and find those numbers, the molar masses, So the molar mass of Cl is 35.45 grams per mole, and the molar mass of Hg is 200.59. Okay. 200.59 grams, 1 mole on the top. Once again, given, desired, desired. Or we learned the trick of going that if we're going to go from grams to moles, we just divide by the molar mass. And for chlorine, that would be 35.45, and that would be 1 mole. So you take 73.9 and you divide by 200.59, and that would give you, since we need 3 sig figs, 0.368. And 26.1 divided by 35.45, that would give us 0.736 for chlorine. So 0.736. Okay. So what do we do next? How do we go to the empirical formula? Well, if you compare these two numbers, that should give you information about how many atoms of each you have. But what we do next is we always divide the larger number by the smaller number. And here, notice how we have less in moles for Hg while we had more in mass for it. So again, the molar masses are different here. So what we do is we take the smaller number, in this case, this is the smaller moles. And here's the rules, is that you always divide larger or largest, whatever, number of moles or number of mole of substances by the smallest, to obtain the ratios of atoms. Very well. So that's our smaller. So we go like this. We say Cl 0.736 divided by the moles of Hg, 0.368. And that gives us 2. Twice as many. That's how you interpret it. Twice as many chlorine atoms than what? Hg. Now, of course, traditionally, some people do that. They just divide Hg by itself. But I mean, we know any number divided by itself is a 1. But it's nice to see it. So here it is. Cl is 2. Hg is 1. Our formula should be Hg. That's a 1. We don't show it. And Cl 2. Now you should know why we wrote the Hg first, then the Cl next.